7.4 Exponential Growth and Decay. That's a complete and total misleading statement. This is actually much more about logistic. No, that's later, pardon me. Much more about separating variables and how that kind of works. So yada, yada, read. Long story short, if you can break the X's and Y's apart, and by the way, it says one more integration. It should just say another, because there's another coming next lesson. Break the X's and Y's apart. Let me give you an example where you can't. dy dx equals x plus y. I can't get the y down here and the dx up there. So cannot separate variables. However, here we can. So we get dy dx equals x squared y squared. Now I can put anything with an x on one side, anything with a y on the other. Dy over y squared equals x squared dx. Let's put it up front, y to the negative second, dy equals x squared dx. Let's slap our integral sign in there. Add 1, y to negative first, divide by negative, we get negative 1 over y equals x to the third over 3 plus c. A lot of people bother this. Well, shouldn't there be a c here and a c there? Let's say it was c1 and c2. c2 minus c1 is the c. It doesn't matter. It all washes out in the end. So here we are, but we got a little bit more to do. Negative 1 over 1 equals 1/3 plus c. Subtract 1/3, subtract 1/3. C equals, my math is correct, negative 4/3. And now things get a little loopy because we have this y on the bottom. So negative 1y equals x to the third over 3 minus 4/3. We want a y equals. Well, we don't always get it, but we might as well see if we can. Let's bring the negative over and let's use the common denominator because we're going to be doing some flip-flopping here. So 1 over y equals 4 minus x to the third all over 3. Cross multiply y, 3, 4. Y equals 3 over 4 minus x to the third. I don't believe that worked. Let's plug in 1. 4 minus 1 is 3 over 3 is 1. dy dx, I get, now this is where life gets really fun. Dy dx just gives me an x. Well, how are these equal then? Because if I plug this back in, or when I do the derivative, if I plugged all this back in, I can get x squared y squared. It's very cool math. I would actually do that if I were you. I'd find dy dx. Let's write this, the negative first is negative 3, 4 minus x to the third to the negative second times negative 3x squared. And yeah, 3 over 4 minus x to the third negative second is y squared. Off you go. Pretty cool. I think it's pretty cool. And fine, I'll show you. So, just for the fun of it, dy dx equals, write this up top, 4 minus x to the third negative first. Negative 1, 4 minus x to the third to the second, in other words, the negative second, times negative 3x squared. Something's bothering me. What happened to my original 3? It's very upsetting. Times negative 3x squared. Get 9 here. Yep, that works. So this also equals 9 over 4 minus x to the third squared times x squared. We'll look at what y equals, 3 over 4 minus x to the third. There it is, y squared x squared. How cool is that? Anyway, so we're going to use this technique in a little while. Notice we got a y on this side. We're going to bring the y over and the dt up. Exponential growth is right here. That's how exponential growth works. It's some constant, or the derivative of y with respect to t is y. So The more material there is, the faster it grows or decays. The slower, yeah, you get the idea. So off we go. dy over y equals k dt. ln absolute value of y equals kt plus some c. This gets weird. It. We're going to keep the absolute value, and then suddenly it's going to vanish, which is upsetting to me, but hey, life goes on. So this is e to the kt plus c. E, yeah, again, I'm not just going to throw it away. Y equals plus or minus. We're going to rewrite this. Quick lesson for you. X squared times x to the third is x to the fifth. I can break this apart into two things that add up. Here's two things that add up. I can break it apart and write e to the c. Yes, I put the last part first. And e to the kt. We like to call all of this just a, and typically is the original amount. That's why it's a, amount, original. So that this becomes y equals a times e to the kt. So we use this separation of variables, and it's a common problem in AP. You'll see it, not often, but you'll see it to set this up. And then it's like, well, do I have to remember how to do all this? No, I'm just going to get this. This is where this PERT came from. Principal e to the RT, and we use a and k instead. All right. So if k is greater than 0, exponential growth. If k is less than 0, exponential decay. And by the way, I really enjoyed this aspect of the class. You kind of get to see behind the curtain. When your math teacher gave you this formula, just said, just deal with it, take it. Now you're actually smart enough to be like, whoa, whoa, whoa. Where did this come from? And you can show it. So kind of neat. Anyway, we're going to take that and do math with it. I know it's a shocker. So it's the law of exponential change. If y changes at a rate proportional to the amount, and we get y naught equals t. Yeah, okay. So there it is. Y equals y naught. I used a, e to the kt, constant k. We just did all this. So this is how continuous compounding works. Just a reminder, here's our formulas. All right. Not most banks pay interest, right? They actually, yeah, right. They usually calculate monthly. That means if they calculated yearly, you put $1,000 in, and then you took it out after 360 days, and they had never said, well, we calculate our interest, $1,000 in, 350 days later, still 1,000. Okay. If you were to calculate it monthly, at the end of the month, they would calculate your interest. Or if they calculated it daily, or if they calculated it by the hour, by the minute, if you keep making that increment smaller and smaller, you get continuous. All right, they call it how often you're compounding. So you put 8,000 in account, pay 3% annual interest. How much will you have in 8 years versus compounded quarterly? So this will be continuous. So how much you have is 800 times e to the 0.063 times 8 years. All right. So I'm going to put it in the calculator. I got an answer here, but I don't trust anything. So we'll go right here. 800 times second e to the 0.063 times 8. 1,324.26. And if we did it quarterly, it gets a little weird. We have to divide things out to make it basically like there's 32 periods. And yeah, I don't want to get into this. So y equals 800. 1 plus your rate, 0.063 over 4, and then we multiply 4 times 8. So hey, this is how much it calculates every quarter, the rate divided by 4, because it does it 4 times a year. Put it all together. $1319.07. For those who are saying, why aren't you rounding to 3 decimal places? Because it's money. So who really cares? Is it worth it over 8 years, $5? No, it's not. Unless you happen to be investing billions of dollars, in which case it's kind of a big deal. So what other things compound continuously? Populations, but not really, not with human nature. As we become wealthier and richer, and the whole world is becoming wealthier and richer, we don't have as many children. But if it's really big, then off you go. And this was, when journalists learn basic math, they freak out and write articles about how we're becoming overpopulated, which is ludicrous. But anyway, that's growth. And then almost all chemicals. So you'll see this in nuclear engineering, nuclear chemistry, and then other chemicals like things like DDT. They decay over time. They're made in a power plant or a laboratory, and they're made pure, but nature doesn't like things pure. Nature likes things very messy. So over time, they break down. So a radioactive substance, let's find the half-life. That's how long until half is left. All right, and yeah, I guess we'll do this right now. Here's how you do it. Now, this part bothers me because people can't quite get it. There's your original amount. Here is your new amount. It's half. So if it really helps, you can write 1/2 y naught equals y naught e to the negative kt. The negative bothers me. K should just be left alone. But when they put negative, they're indicating that it's decay. So your K will be a positive number, but the formula handles a negative. It's really ludicrous. All right, so we get this half y naught equals y naught e to the negative kt. Divide that out on both sides. 1/2 equals e to the negative kt. Take the natural log of both sides. You get natural log of 1/2 equals negative kt. No, screwed up. No, we do want t. T equals negative ln of 1/2 over k. And with the laws of logarithms, I can rewrite this as ln of 2 over k. And put the negative up here, and 1/2 to the negative first is 2, so it's also ln of 2k. This bothers people, and they tell me, no, I don't buy that, so okay. Negative natural log 0.5, natural log 2. Yay. So do I have this memorized? No, of course not. I just work it out. It's not a big deal. Here's an example where you might want to choose a different base as opposed to E. By the way, they think E stands for Euler. Pretty sure. Hornets, growth. 10 hornets on May 1st, 50 hornets 30 days later. How many days after May 1st? get 100. So let's use a base of 5 because it grows 5 in 30 days. So our original population was 10. So y equals 10, and then it grows by a factor of 5. Yeah, I would never do this problem this way. I don't know why I'm doing it this way. This bothers me a great deal. I'm going to try and do it twice. See if we get the same answer. It's growth, so it's positive. I do not like the way I did this problem, so I got to think about it. Oh, okay. So we're going to go with 1 over 30 times t. In other words, 30, plug it in there. 30 over 30 is 1. 5 times 10 is 50. So we really tortured the model. Okay. But there it is. There's my model. So now we want to know how many are 100. 100 equals 10 times 5 t over 30 divided by 10 divided by 10. Remember that 5 and the t over 30 are glued together. 10 equals 5 to the t 30. Let's do log base 5. Because then these cancel. And then I just take that multiplied by 30. So let's go with 30 times math log base. If you don't have this on your calculator, you can't do it this way. It's not the end of the world. 10. It would take 42.920 days to get to 100. How about we do it the way I would have done it? There's 10, so y equals 10 times, we don't know, a to the kt. And we know that 50 equals 10 a to the k. My brain just cramped up. 10 hornets, 50 hornets, 50, 30 days later times 30, but I have 2 variables. Oh, E, what am I thinking? That's really silly. E. Times 30. 5 equals E to the K, 30K. ln, K equals ln of 5 over 30. Don't mess with that, just leave it. Oh, goodness, I hope I didn't have the page blocked there. All right, so now I have my model. So we want to know 100. 100 equals 10 e to the ln of 5 over 30t. Divide by 10, divide by 10. 10 equals e to the ln of 5 over 30t. And we natural log, gone, divide by that. So t equals natural log of 10 over natural log of 5 / 30, which is 30 times natural log of 10 over natural log of 5. 30 natural log of 10 divided by natural log of 5. 42.920. I always use E. I never use a different base. But that's kind of a slick little way to show that you could. So scientists use this carbon-14 dating. It has a half-life of 5,700 years. How old's a sample? First things first, we need to get the K value. So 1/2 equals E to the 5,700 times negative K. Do me a huge favor and don't ask me where I got this from. You know that Find half-life, we do this first. Cancel these, get 1/2. Please don't ask me that. It makes me crazy because I understand stuff is challenging, but I showed you and you're like, oh, I don't understand what's going on. That means you didn't think at all. So that's painful. They cancel. So my K is negative ln 1/2 over 5,700, which we showed is actually ln of 2, 5,700. Okay, 10% left. So original 100, now we have 10 pounds, 10 over 100 is 0.1. So you can do the same thing, just like 50% left. You get 0.1 equals e to the ln of 2 over 5,700 times t ln t equals ln 0.1 over ln of 2 over 5,700 times 5,700. times ln 0.1 divided ln 2. All right. I should not have a negative. So I changed the problem and didn't realize I changed it. Confused why I have a negative. Oh, that's going to give me a negative. I know that's going to give me a negative. How old's the sample? 10% left. 10 over 100. Oh, I guess it's going backwards. The negative. 18,934. 990 years. In other words, really, really stinking old. By the way, I know how carbon-14 dating works. It's complicated, but it's pretty cool. So last thing, and you will not have to know this, I think I put it on my test, but it's not on the AP, but the general concept is Newton's law of cooling. So let me show you how this works without thinking too hard. Something starts at an original temperature, T0, and then there's the surrounding temperature, Ts, and it just heads on down there. So T equals T0 minus T e to the negative KT plus Ts. In other words, it's a logarithmic starting up here, the amount between the two. So say this is 20 gap between them, and then it runs down from 20. That's it. So you just blast this out. I'm not going to take this too seriously. Again, because when I see this on a AP test, it's usually done where you have to separate the variables and run with it. T minus the surrounding temperature is 18 degrees equals the original temperature 98 minus 18 times e to the negative k t. I know this value now. We'll just call it t for now. So this is t equals 80 e to the negative kt plus 18. All right, now they say this temperature is found to be 38 degrees after 5 minutes. How much longer it takes to get to 20? So we have to do all of this math. 38 equals 80 e to the negative k times 5 plus 18. Subtract 18 over 20 divided is 0.4. Natural log of 0.4 divided by that. I get k equals a natural log of 4 over 5 with the negatives and everything, the way it works out. So if that's my k value, how much longer to get to 20? So here it gets a little weird. That takes 5 minutes. So the other one is 20 equals 18 plus 80 e to the -1/5 ln. That's where I screwed up on the previous page. Very upsetting. That's why I don't like the negative thing. All the way down here, it's negative growth. I found k equals a positive. I put it in here, it's got to be a negative. So there should have been a negative here, which would make that positive. Told you I don't like the way they handle it. But that's just me. So 20 minus 18 is 2 over 80. Natural log both sides. Divide that out. T. Why does it say -1/5? At least you're really negative. Sorry about that. I get t equals 13.3 minutes. That's not the question. 8, and it should be not be a single decimal. 8.3 minutes longer. Whew, that's hard work. You can also put this in your calculator. All right. Estimate the coffee's initial temperature. I wasn't going to do this, but I get paid the big bucks. And it's going to make me laugh, so I should stop talking like that. Clear, enter. Enter. 2, enter 5, enter 10, enter 15, enter 20, enter 25, enter. Six 4.8 9.0 0.4 2.0 2.5 2.2. That calc, and I believe we're looking for an exponential. List 1, and I am shocked that this is list 2. Second, L2 frequently lists alpha 1. Oh, stupid. Alpha y1 calculates. So that's an exponential. Let me think about this for a minute. I got to think about how I want to do this, because that's not the one I wanted. I don't think it's here. And it's not. I'd have to do this differently. Long story short, you're going to get the temperature equals 4.5 plus 61.66 times, I think that's what we just saw, 0.927 T. Won't be doing this one in class, so you can ignore it if you're watching the video. Woof. That's it. Good luck and happy mathing.